In this video, we're going to go over the 6 steps of statistical investigation and go through a few examples of how we actually go about performing a statistical study. So the first thing to realize is statistics versus anecdotes. Okay. We all heard that smoking causes cancer in one form or another, but inevitably, what always happens? Someone knew a grandmother that someone's grandmother lived to be 105 years old while smoking a pack a day and never got cancer. So checkmate, right? They've beaten you. Smoking doesn't cause cancer. Well, that story can be true, and is sometimes. However, if we look at data, we see that those that smoke are more likely to get cancer than those who don't, which means it says it's more likely. That means that you are going to find people that don't smoke that get cancer. And you're going to find people that smoke who don't get cancer. And yet, those who smoke will get cancer more often than those who don't. That's what statistics is able to say. Now, we can't base scientific conclusions on anecdotal evidence, like the 105-year-old smoker. What we need is evidence from lots of sources. And that's why the word data is actually a plural. Usually we think that a word is plural if it's got an S on the end. Well, data is one of those words where no, it's actually plural already. And so when you say I want to look at the data and you're only talking about one thing, you're contradicting yourself. If you're looking at data, you're looking at multiple pieces of evidence, multiple sources. And that's what statistics is all about. It's the science, it is a science, of producing useful data to address a research question, analyzing the data and drawing appropriate conclusions. So statistics always starts with a question. And this is something we do all the time. We look around, we notice things that are different, that are out of the ordinary, and we wonder, why is that? What caused that? Those are all statistical research questions. And so the first step is to ask a research question. And most people, when they think research, they may think of like an English paper or a term paper. No, it's a research question is just a question that you can then go out and measure yourself, conduct your own research. And so once you've got a question, then you can actually go out and get information, collect data. And then once you've measured whatever it is you want to measure, then you can explore the data, graph it, or put it into a table, some way of displaying the information in a useful way. Then you draw inferences. And a lot of what we see in statistics, a lot of the crunchy scientific stuff comes in here. Is the information useful? Is it significant? That word significance is going to come up a lot in this class. And then formulate conclusions. Now, some people think that inferences and conclusions are the same thing. Not exactly. Here we explore the data and say, what does it say? In step 4, we say, is it significant? Because sometimes some things just happen by chance. And if they happen by chance, statistics is going to tell us that, and we can't conclude anything. But then step 5 says, okay, we've got our information, we've figured out what it says, but can we use that to talk about a bigger group? Can we take this small group of people and have that generalized to the whole population? Sometimes yes, and sometimes no. And then once we draw our conclusion, we always look back and look ahead, because statistics is never done. Once you ask a question, the data never totally agrees with the way you think it's going to. If it does, odds are you've cooked the data. And so some way, somehow the data got away from you and you said, well, that didn't go the way I expected. And so oftentimes you have to look back and say, well, that didn't work, but look ahead and say, well, I can do another statistical study and address whatever new question arises. So let's look at an example of the 6 steps of statistical investigation. So, organ donations. Now, you ask any person on the street and they're going to say, yeah, organ donation is a good thing. But then ask them a second question. Have they signed their driver's license for organ donation? And they're going to probably squirm at that because more often than not, a lot of people probably haven't. Now, that's partially because different states and different countries recruit organ donors in different ways. And so that leads us to a question, a research question. There's our step one. Do these different methods result in different sign-up rates? If the way we recruit people for organ donors, does that have an impact on whether people say yes or no? So, step one. In general, is there a way to make someone more likely to become an organ donor? That's our general question. But that's very vague. And how do you measure that? How do you gather data from that? You can't. But the general research question is a starting point, and then we be more specific. How can we answer that? So the more specific question says, does the default option given to driver's license applicants affect their chances that they become a donor? So when you apply, what's the default option? Is it yes? Is it no? That's what this study went about to figure out. So now we design a study and we collect data. Okay, so how are we going to do this? So in this case, what researchers did is they recruited participants, volunteers, and they pretended to apply for a new driver's license. So they set up a fake DMV, they had them stand in long lines, they had to have them fill out paperwork. Now the participants didn't know that different donor options were offered, or that organ donations was the focus of the study. They probably thought it was a study of how to make the DMV lines shorter. That's probably what they thought. Now, some were forced to decide yes or no without a default option. Now, some were told that the default option was no, but they chose to be a donor. Others were told the default was yes, but they could choose to not be a donor. And for our purposes, we're going to call this group, the group that had to decide, the neutral group. This group, the ones who told the default was no, but they could choose, we're going to call them the opt-in group. And then finally, the third group, who was told the default was yes, but they could choose not to, that's the opt-out group. So, what did the data say? 41% of those who had to opt in became organ donors. Excuse me. 82% of those who had to opt out became organ donors. And 78.6% of those who had to make a choice became organ donors. So, very big difference. If you had to choose, if you had to opt in, organ donation was much lower. But if you were automatically opted in, more people chose to be a donor. Or if they had to choose yes or no on the spot, more people chose to be a donor. So there's a difference in the data. So that's step 3. So step 4. So the researchers analyzed the differences to see if they were large enough. Because what if these were a little closer together? Well, that may not be significant. That may just be the random chance of different people. The question is, are these differences big enough? Are they significant? And that's what step 4 is about. And what they came to the conclusion was that neutral and opt-out versions do lead to a higher chance of agreeing to become an organ donor. So if you make people choose yes or no on the spot, or if you force people to have to decide to opt out, more people are going to choose to be an organ donor. That is statistically significant. Now, step 5 says, how can we formulate our conclusion? So the researchers concluded that the neutral version causes an increase of organ donor participation. We're going to talk a lot this year about causing something versus affecting something. Because I can affect a lot of things, but I can't cause as many things. And so the bar for saying that something causes something is much, much higher. Now, the problem is these participants were volunteers, so they don't really represent a large group of people. So is this a universally applied result? Unfortunately, no. But that leads us to step 6. Step 6 says, look back. What were some of the drawbacks? Well, they had to imagine how they would reply, not in reality. So some of them may have just been playing along. So a new study might look at people's actual responses. That's one way to fix it, make it better. A new study might examine whether if you give people educational materials ahead of time, if that will increase organ donation. And then a third study might include more participants from a wider demographic. More people is going to give you a better chance to see how a wider range of people will respond. So that's these 6 statistical steps applied. So I'm going to give you a little bit of additional practice now. We have 2 more statistical investigations, and we're just going to go through what the 6 steps are. Pollsters claim that by randomly interviewing 1,500 adult Americans by phone and asking them for their opinion about a certain social issue, they can paint an accurate picture of how all 230 million Americans felt about that issue. They claim that they can estimate the president's approval rating within 3% of the actual number. That's why you hear people say plus or minus a few percentage points. Suppose a CNN poll of 1,500 Americans showed that 518 said they approve, 802 disapprove, and 180 either declined to answer or had no opinion. So, what's the research question? The research question is, what's the approval, what percent of Americans approve of the president? Now, we're talking about all Americans, but unfortunately, CNN can't contact all Americans. That only happens once every 10 years, called the census. So all they can do is just make phone calls, usually during dinner time, and they ask people their opinion. And once they get 1,500 people who don't hang up on them, they've got their data. And so this data says, well, 518 say they approve, 802 disapprove, and 180 either didn't answer or had no opinion. So it seemed like the president is definitely have a low approval rating. Now, is that significant? Well, we're going to teach you about that later on in this course. Right now, you're not able to tell whether that is a significant, that is significant or not. Now, can we formulate this? Can we generalize to all Americans? That's hard with CNN polls because a lot of people don't want to be bothered by them. And in addition, CNN usually calls at certain times of day. Well, other people may be working. So you may want to look back and say, well, it's the best we can do right now, but maybe a better study would be a wider range of people from at different times of day. Now, the other one, groundwater tests near oil and gas wells are conducted to ensure that chemicals which are forced underground for fracking purposes don't mix and contaminate the drinking water of nearby communities. The standards for water purity is that drilling chemicals do not average more than 100 parts per million. The North Dakota Department of Environment fines companies $100,000 for any well that violates the standard. Tests conducted near a well in Minnow, North Dakota on 8 days in December 2012 show an average of 102.6 parts per million. All right. So, what is the research question? The research question is this well polluting beyond the industry standard? Are they polluting too much? They can go up to 100 parts per million and no more. So what do? They pick a well, they test the groundwater near it on 8 different days in December 2012. And what do? They average it out. So, does that mean that this well is polluting? Well, I didn't give you 8 numbers. It could be that 7 of the numbers are low and 1 of the numbers is way high, and it just pulls up the average. Does that mean the well is polluting consistently? Well, not consistently. So, as far as significance, we don't know that yet. We will. Does this reflect this well at all times? Well, it was only in December of that year. Maybe in December they drill more often, or maybe they drill less often. Or they studied it in 2012. Perhaps they should study it in a different year. So Does that mean that this well is polluting at all times? Maybe, maybe not. As with all things in statistics, more data is always better. All right, thanks for watching. If you have any questions, send me an email and I'll get right back to you.